Hello everyone. My name is Michał Kowalczyk and I work for TomTom, and that is the reason why I'm here today. I would like to say a few words about combining those new languages, that is Swift and Kotlin, with old languages like C or C++. And first question that you probably ask me, why C++? Why? And that is really good question, because it doesn't be really smart choice. This C++ is full of really dangerous features, and a list of such features. So for instance, if you work for Google and you want to use exceptions in C++, you cannot. Okay, so I think that's bad, and I would like to tell you that in TomTom we are much better, but unfortunately in my project, if I want to rely on operator precedence, I cannot. I need to wrap all the math into brackets. So I guess that's even worse, but still I'm happy, because if I work for Bloomberg, then I only need to learn these 50 pages of their coding standards for C++ by heart, and then I'm good to go. I can code some C++. Yeah? So you see that C++ is a really dangerous language. You shouldn't use it. But okay, if you must, then let's find out what are reasons for using C++ here. Yep, so in TomTom, we are producing maps and navigation. This company exists for over 25 years, and the oldest code that I saw in our code base has around 25 years, I guess. So probably that is the reason. This age is a reason why it wasn't written in Java, Kotlin, Swift, JavaScript, any other languages. That was written in C or C++. And we have tons of lines of code written in those languages. And we don't want to throw it away. So the question is what we can do nowadays when Word is mobile, right? Our clients come to us and ask us to run our code on Android devices, iOS devices, some custom other devices. So they want from us Java API, Objective-C API, and the question is, should we translate all the code that will be written in C++ to Java or Objective-C? And yeah, we might do that, but that would be a lot of code duplication, because let's say that we have those millions of lines of code and we need to triple them, yeah? So there's a lot of code duplication, and also that could be quite expensive in maintenance, since each new feature that we create, we must create 3 times. Each bug that may occur also 3 times. So that is not the best approach, and it seems that more reasonable is to use a so-called language bindings. And fortunately to us, if we have our code in C++ and we write some Objective-C++ wrappings, then we can use it in Objective-C. So we can reuse our C++ code in Objective-C. That's cool. We can also do the same with Java. So if we use C++ and write some Java native interface code, then we can reuse all our code base in Java. So we don't need to write those millions of lines of code one more time. So that's good for us. But maybe one day our clients will come to us and ask us, we want your API in Swift or Kotlin. And we need to have some answer prepared. So fortunately to us, if we have those wrappers in Objective-C++, and we will create a small bridging header for communication with Swift, then we can also use the C++ in Swift code. So that's good. And The same goes to Java and Kotlin, because Java and Kotlin work each other very well. So we can also deliver our code to Swift and Kotlin. And I prepared for you an example, but I wouldn't like to tell you about features that we create in TomTom. Probably not all of you are interested in this navigation stuff or maps. So that's why I prepared a sample application about push-ups. And I guess there are some Polish people at the audience. In Polish language, when you say push-up, you mean this. But this is not what I meant. By push-up, I mean this. So something that is really close to each software engineer exercising. Yeah. So I would like to create an app that will let you count the number of repetitions of push-ups, and I would like to have it on Android and iOS. Yeah. First thing to ask is how to detect a single push-up. Well, we are at mobilization, so we should use some smartphones. So when you are making these push-ups, you have this smartphone, and we can use some image processing for detection if you are at rise position or if you are at lowered position. And here, probably because I'm a bit lazy, I just used existing algorithm for detecting face. So if my cell phone is able to detect my face because it's far from me, then I'm in rise position. And if I'm really close to this cell phone, because I'm at lowered position, then it will detect a single push-up. And then, by repeating this process, I can count the number of repetitions. So yeah, so we know how to do it. And let's think about architecture. So we have those two platforms, one Android, the other iOS, and we of course might find one image processing library for face detection for Android, the other in iOS. Then once we can write business logic in Kotlin, after that also the same business logic in Swift, and then of course some UIs in Kotlin and some UIs in Swift. But we still see that there is a code duplication here, because we write this business logic twice. Also, because we use two different libraries, one for Android and one for iOS, there might be differences in implementation of this face detection algorithm. So we might provide unequal user experience. So we might try something different, and we might put business logic on native side. So it will be just written once, let's say in C++, and the same with image processing library. So if we have it in native code, we can use it in any platform that supports C++ or C. That's a lot of different platforms. So the only code that I would like to leave on a so-called platform-specific layer is code for UI, because it's really hard to write such code in C++, because there are so many APIs, and it is just too big codes to use it in C++. Kotlin is far better for writing those Android applications, and Swift far better for writing iOS applications. So yeah, the other layer that we have here is a platform agnostic layer, and here there is a written code that doesn't really know what platform it executes on. So it doesn't use any platform-specific APIs. Okay? So regarding this image processing library, we might use OpenCV, and it satisfies our requirements. It is written in C and partially in C++. It has interfaces in C++, and it has also wrappers for Python and Java. So with those wrappers, we might easily prototype our solution and then write the final production code. Okay? because we have those wrappers, you might think that, okay, if it works with Java, I don't need to write this C++ code, right? But there are no Objective-C++ wrappers. So that might be a solution if you develop only for Android, but it won't be a solution for iOS. What is more, you will find in OpenCV documentation that, yes, there is this opportunity to create applications fully in Java for Android, but there are some cons about this approach. And first is performance. So each Java native interface call needs some calls, needs some processor cycles just to execute, and it is much more than executing a single method. So when you have this beautiful optimized code of OpenCV and you just use Java native interface to call those methods from OpenCV, then you lose all that OpenCV brings to you. Okay? And the other thing is this Java API doesn't provide full opportunities that OpenCV brings. Full opportunities are available only in C and C++, so maybe it is better to choose C++ just to get all opportunities and don't find out that, I need this function, but oh, it is only available in C++, right? So, and at so-called advanced level, you have this performance, you have all APIs, and much more. The third reason why to use C++ here is this Stack Overflow matrix. So you see that there is a lot more questions in technologies combination of Java and Android than in case of Android and C++. So it seems that it is reasonable to use Java on Android, right? But on the other hand, you see that there are a lot more questions asked about C++ and OpenCV than OpenCV and Java. So we see that if we want to use both of these technologies, we have to use both Java and C++. At least that would be just easier because there is much more support in those combinations of technologies. So if we decide for writing this OpenCV code in C++ at native level, then we have a lot of support. And then if we decide to write Java code at this platform-specific level, then we also have a lot of support. So I think there are many reasons why to approach this problem in this way, to write some code in a native layer. Okay? At platform-specific layer, as I said, we might put UIs, we might put some animations, some platform-specific APIs, like, for instance, text-to-speech. So we will hear after each repetition that that it can't. Okay? So just to sum up, we put Kotlin and Swift code for UI. We use C++ for business logic and OpenCV. And the last thing is this glue code, so these language bindings. And we might, of course, handwrite it, because it's still just a C code or Objective-C++ code. But we might do better, since there are glue code generators. So it is great that we don't have to write all this code by ourselves. And there are two approaches available on the market. Maybe there are more, but two are, in my opinion, just most interesting. One is called Swig, and it has existed for over 22 years, and it has opportunities to generate a language binding to many, many languages, like Java, PHP, JavaScript. Probably Swig is used for generating some binding code for many JavaScript technologies used on Android. Okay, and how it works? As an input, it takes configuration file that may include these C or C++ headers, and as output, you get this glue code, so binding between C++ and Java, or C++ and PHP. The other approach is to use Djinni, and Djinni is rather quite new technology. It exists for 3 years, and it is rather focused on mobile applications. So here you have less languages that are supported: Objective-C, Java, and Python. But for our needs, that's enough. That's sufficient. Yeah. So the idea of generating this code is quite the same, because you also need some configuration file. But this time, this code is not created in with use of C++ headers, but with something that is called IDL, that is Interface Definition Language. And this is a really simple language. You can learn it in 1 hour or less, probably, if you know some object-oriented paradigm. Okay, and as output, you get this glue code, the same as in case of Swift, but also you get interfaces to each language that you use. So interfaces for Java, interfaces for Objective-C, and interfaces for C++. So there is a difference between Swift and Djinni, since if we use Swift, this is C++ who drives the project. So if me, as a C++ developer, I decide that I want this API to look a bit different, then all people that are using this generated code will experience this change. And in case of Djinni, this is IDL who drives the project. So if me, as C++ developer, I want to change something, nobody feels it. Maybe my project will stop to compile, but that's my problem. And yeah, this is the agreement of programmers that, okay, we need this new API or change something. So in this presentation, we'll use Djinni, since it has these Objective-C bindings that we need for Swift code. Okay. How our application will look like. So we'll have this big number of reps. We will have 2 buttons, one for starting and pausing push-ups detection, and one for resetting all the activity. Okay, it's quite simple. And optionally, we may also display some debugging image from the camera to see if our algorithms work well or not. Okay, so now let's switch to this IDL. So let's write some code. IDL may contain 3 types of structures. One might be enumerations. So yeah, this is available in each language, I guess. The other one are records, and records are just wrappers for data. No actions there. And third one are interfaces. And interfaces, as probably in most of languages, are just sets of methods. So we will need at least 4 of them for starting, pausing, resetting, and checking if we already started or not. And yeah, those methods that doesn't have this colon at the end just return void. Those that has something at the right of the column, they return some value. So here is started returns bool. Okay. Then we need a listener for informing Swift code or Kotlin code that this push-up was detected. So you see that next to interface of push-up pal up, you have this +C, and that says that this interface will be implemented on C++ side. And you have also this interface push-up listener that has this +J and +O. So +J says that it will be implemented in Java or in Kotlin, and +O, Objective-C or Swift. And it has one method on push-up that accepts 1 parameter number of reps. The last thing is how to create an instance of this push-up pal app that will be implemented in C++. How to create this instance in Swift code or in Kotlin code. And we have this static factory method that may create this interface, and it should accept all the things that are specific to platform, right? So every parameter that differs between platform should be passed to such method. And of course, this will return push-up pal app. Okay? So how to run Djinni? Djinni accepts a number of different parameters, but most of them are quite straightforward. So this is a command line tool, and it accepts parameters specific to Java, like where this code should be generated, or what package should be used in this project. Okay? The other thing is C++ code, and here it's the same, but in C++ we have no packages, we have namespaces, and we have the same for Objective-C, Objective-C++, but here we have prefixes, right? There is one special flag that is needed for Swift, and this is my little contribution for Djinni. And thanks to this bridging header, we may just reuse this Objective-C++ code into Swift. Okay? And the last thing is, of course, the path to the interface definition language file. So the one that I showed you in a previous slide. All right. So now let's create an Android project. So first thing that we need to do is, of course, create a project, and we need to tick this include C++ support. Okay. After we finish with this dialog, we also need to say where is our native development kit located, and we set it in local properties. If you have no native development kit, Android Studio will offer you to install Android native development kit. But of course, you can use the other kind, ones of that are on the market. So next thing is writing some Kotlin code, and we start with an empty activity. Then we need to create this instance of push-up pal app. So as you see, it looks the same as writing Kotlin code. We may call this create method on push-up pal app, pass there some parameters, etc., etc. It's the same. The next thing is setting a listener, and this is a way how to inject Kotlin code into C++. Right? So in this way, because C++ is calling this this listener, this how it's called, on push-up, we may execute some Kotlin code in C++ and C++ into Kotlin code. All right, and of course we need to write handlers for all these buttons. So when you press start, when you press pause, and when you press reset. There is one thing specific in developing Android apps, or even, I should say, Java apps. When you want to use this native code, you need to load a shared library, and we do it in companion objects in it. And shared libraries here are loaded in runtime, right? So in case of many other platforms, we load it during compilation time, during linking time, but here it happens during runtime. So the question is how to build such shared library, and for this we use CMake. And CMake is a tool that we use in C and C++ words for creating our build systems, just to make them more generic. And Android Studio lately started to support CMake, so now we can also use it in Android projects. And how such CMake file looks like? It has some special command that is called file that loads all the sources that you wrote in C++. It has also include directories that says where all these dependencies to our project located. So we have our own headers here, placed in native folder, and we have some dependencies like dependencies from Djinni, dependencies from Objective-C, etc. And the next thing is just say that we want to create a shared library from this code, this source. Okay. We also said that we will use OpenCV. Fortunately to us, guys from OpenCV, they prepared this shared library, so we don't need to build it by our own. We just can use existing one, and those shared libraries are specific to Android ABI, so we can say that it is specific to Android architecture that it will run on. So in this way we can get the proper one for our compilation. And the last thing, we need to link these two shared libraries into one. So yeah, you can use this code and it should work. So now you have this Android app ready. The next thing that you need to create is, of course, iOS app. And here there is a difference between iOS and Android. As I said, in Android, you need to load this shared library at the runtime. And here you need to do it during compilation time or link time. And because of that, you need to say where are all these dependencies located. So you need to set location for headers. And we use, of course, the same paths as we used in case of Android project. We need to say where are sources. So all these C++ sources and Objective-C++ sources. So yeah, you just set them there. Maybe there's a better way to set up a project. I'm not so iOS developer, so if you know one, please tell me. And the last thing is, of course, this bridging header. So yeah, thanks to that, you can use Objective-C++ code in Swift. Okay, when you set all these things, you can start writing Swift code, and it looks quite the same. So we start with an empty view controller. We have only these references to those three components, label and two buttons. Then we create this instance of push-up app. So as you see now, it looks like writing code in Swift. We have all these prefixes, and yeah, you use Swift syntax. We also create this listener, so we also may inject this Swift code into C++ code. And of course, write code for handlers for clicking buttons. Okay, it looks really the same. Last but not least, how to write this native C++ code. So from my point of view, as a C++ developer, I'm really happy about the code that Djinni generated to me. What I need to do is just get this generated push-up app and derive from it and override methods to write some implementation for starting, stopping, etc., etc. Okay? The only thing that you won't find at this screen, but you will find at this screen, is this create method that just return a shared pointer to implementation of push-up app interface. And as you see, we pass parameters to it, and it should work. And it is really nice in Djinni that is using a so-called modern C++. So it has all these new features that make writing C++ code really, really fun. They have these smart pointers that reduce problems with memory deallocation to minimum. So yeah, that's really cool. But I wasn't supposed to say that C++ is cool. Let's keep things as it was previously. So I forget about one thing, and that is what about displaying this image from camera for debugging purpose? And yeah, now it will get a bit complicated, but let's be brave. So we want to display camera image, and OpenCV has some solutions for us. We can use this Java surface view for displaying it on Android, or CV video camera for displaying it on iOS. In case of the latter, you need to pass the image view, so it will know where to display this image. In case of the Java surface view, you just use it in your layout file. Okay, then it is the same. So you register for camera updates, and you get a frame, do something with it, and it will display your modified frame. Okay, and there are two approaches that you may use here. You may pass to native code this Java surface view and CV video camera, but that would require from us creating two different methods for Android and for iOS, right? Let's say draw this debugging information on Java surface view, because the type is different, yeah, and C++ uses strong typing, okay? And the same for draw debugging information on CV video camera. So that is not generic approach, and as I said on this platform agnostic layer, we should rather keep things that are specific, that are agnostic to platform. Sorry. So the other approach is to just pass to this native layer a mat, and a mat is a matrix, so a frame from the camera. So we'll have some method that will accept it and draw these things on it, and then we can display it on our screens. Okay, so we need to modify our IDL, and we need to add this one method that will accept this parameter. But there is one problem. Djinni supports some types. It supports, of course, everything that you defined in IDL, so all these enumerations, records, and interfaces. But yeah, besides built-in types like Boolean, integer, float, etc., it doesn't support any other types by default. So when I said at previous slide that I want to use some mat, Djinni will ask me, what is a mat? And yeah, I need to answer this question somehow. So fortunately to us, Djinni provided an opportunity to explain it. So if I define everything that Djinni requires to use this mat at a YAML file, then it can generate some code. I need to also say how to convert a type between C++ and Java, or C++ and Objective-C. So for that we have those converters to CPP, so from Java to CPP, or from CPP to Java. And in our case, we don't need to write the latter, since we only have a method that that accepts this parameter, and yeah, it must be implemented on the C++ side. So we have no situation where C++ should return it. Okay, and yeah, how this YAML file looks like. We need to say a few words about a mat type. Sorry, one that would be the type in terms of Djinni. So it will be a record. The other thing is some attributes specific to C++. So for instance, that may be a type that will be used on C++ side, the namespace and type name. The other thing is where this type is located. What headers, so what dependencies should we include to use this type? The next thing is attributes for Objective-C and Objective-C++. Quite the same. Extra, we have converters that will be used between C++ and Objective-C. And the same for Java. Okay, so fortunately to us, OpenCV has already those types on Java and on Objective-C. We need to just create wrappers. So let's take a look how this mat looks on Java side. It has one field that is called native object and is a type long. That seems strange because long is not an object, it's just some primitive. But when we take a look at this constructor of math, when we realize that this long adder, that's probably something related with address. So that's probably just a pointer from C++ code. And yeah, to initialize a math, you just need to pass a pointer, and native object will be initialized with it. Okay, that's cool. So we can easily write a code for this. So now let's go to dark side and let's write some Java native interface code. Okay, so we start with something like this. This is on C++ side converter between Java and C++. We have this 2 CPP converter, and the first thing that we need to do is find this math class on Java side. Then when we got it, we need to get this native object field, get its value that is long type, and then just cast it as a pointer on C++ side. Yeah, and we return this, and yeah, we can use now math on C++ side. So that's cool. The same goes for Objective-C, Objective-C++. We don't have enough time for talking about that, but after this talk, you can just come to me and I will show you the example. Okay, so how it works? Well, preparing this application for you for this talk was a lot of fun, but it was also a lot of effort. So you see me practicing this and doing these push-ups. And to be honest, I'm quite happy about that. So I encourage you to use it your own. Okay, so this app is available for you, and you can just, of course, build it and run it. Okay, conclusions. So if you have in your organization some C++ code that is really liked by some programmers, maybe management, you can reuse this code in your Swift and Kotlin applications. Of course, Java and Objective-C too. You can also take advantage of native libraries. So here, OpenCV is a really cool library, and I can use it in my code on Android or iOS. The next thing is, of course, reducing code duplication. So maybe there is some code in your iOS and Android apps that still repeats, and still programmers on each side needs to struggle with bugs that may happen once on one platform, sometimes on the other. When we just write this code in native code, it may happen, those bugs, only in this C++ code. So it is really easy to track it, and we are sure that it will reproduce on each platform or not. Okay, and the last thing is Djinni, that produces this glue code that works in, I think, 95%. Well, so this variant with writing our own converters for a math type is this 5% or maybe less. Usually we don't do it by our own. Okay, I didn't cover anything about Kotlin native because it's still quite fresh project. It is interesting. Just in few words, it allows you to call from Kotlin some C functions, and that seems really cool, but I'm still not sure how the memory model will be solved there. So that is a reason why I didn't want to say things that I'm not sure about. So yeah, it is not covered here. Also, it is possible to have Swift and C communication, and it should work out of the box. So that's cool. And the last thing, that there are a lot of other approaches to generate this code between Swift and C++, but I think Djinni is just the most mature one. So that's why I presented it to you during this talk. Okay, a bunch of links that might be interesting for you. So if you never tried writing native apps on Android side, then please go to this Android developer website for NDK, and you will find a lot of interesting things. Some of them might be not applicable fully now, since CMake is available in Android Studio for just few releases, I think. So because of that, you'll find still some other options to build these shared libraries, but that is not a big deal. And the other thing is, of course, where to find this Djinni. So you will find it in at GitHub on Dropbox account, because Dropbox created Djinni. And the next thing, if you want to try something easy, not image processing at the beginning, then you can go to these mobile CPP tutorials that are really straightforward. If you have any problems, the sections about troubleshootings are really good explained. Of course, where to find Swig, where to find OpenCV, and if you want to try this code that I showed to you, or some other code that I created for just previous conference, please visit my account on GitHub. So that's it, and you can contact me via email, or you can visit my homepage. So, are there any questions?
What about performance? I mean, the video stream from OpenCV to, for example, Android View.
Okay.
Are you able to get, for example, 50, 60 FPS, or what are numbers?
Well, I didn't check numbers. I didn't benchmark it, but as you saw in this Java, I can get back to this slide. This mat on Java side is just a pointer to native objects, so we don't need to pass any data between those layers. We just pass a pointer, and because of that, that should be really efficient. The only cost that we pay is this Java native interface call. Unfortunately, I also didn't measure how single call takes, but besides of that, that should be good.
Is it possible to not use C++ at all, write the business logic only in Swift or only in Kotlin and use it on both platforms?
Well, to be honest, I don't know. I'm just a C++ programmer, and this is how we create apps. I'm pretty sure that they tried Swift on Android because there was this hype for going Swift there, and that happened before Kotlin got so famous. So probably that is feasible. On the other side, I'm not sure if Kotlin can work on iOS. Maybe some of you can answer that.
Djinni is a tool from Google, which we use in our company, and we convert to 100,000 of Java code to Objective-C forms, including headpulse, streams, reflection, and imports.
And there's a Kotlin native, the thing that we were talking about. It's actually developed to be able to compile some Kotlin code on iOS. It's actually in alpha developer preview now, that it will be probably announced in 2 weeks in the Kotlin Conf by JetBrains that they fully support iOS.
Okay, good to know. Thanks.
Well, I had a similar question and we just answered, but the next question I had is, have you tried Google Mobile Vision in your app? Because it looks like it's a better way of facial recognition technique than OpenCV, because OpenCV is just very big blob of very unfriendly API features for a developer, and there's lots of it. And Google Mobile Vision is just simple library for facial recognition. Have you tried?
Well, it was just a project for this talk, so I didn't check all the possible opportunities. Of course, if I write such code for project that we use for TomTom, then that probably would be a better choice. But for this talk, I just use something that is well known and exists in market for many years. So I didn't try it, but probably I will.